So you're recording, right? So I just explain.
Okay.
Okay. So let me just explain to you. So clear up?
Yes.
Okay. The basic equipment. So to do dynamic and static light scheduling, you need to be able to observe molecular motion, right? So this instrument allows us to do both dynamic light scheduling that gives you the aerodynamic size from the diffusion of the object, and static light scheduling that gives you molecular weight, secondary coefficient, and also interaction parameters. So to do that, we need a setup that allows us to have a sample, the light source, the laser that focus onto the sample, and then we have some optics that acquire the scattering characteristic which are detected. Okay, so this sample and the detector is sits on a goniometer that rotates from maybe 5 degrees to 150 degrees because we need to get the angular dependence of the scattering object. For example, I can move the gonio now. So I set the detector. So now the detector is 150 degrees. So I set 150 here. And then I want to move it to 30. So I put 30 and then I'll press OK. The detector will move. So it's moving now to 1 to 30 and so when you finish the experiments, always move the detector back to 150 so that it's not, someone will not knock it, right? It's outside here, someone can knock it and then you can damage right there. Okay, so right now it's 60 degrees and then you will stop at 30 degrees. So we won't be doing the alignment. The alignment is one of the most difficult and extensive tasks to set this up, right? So when someone comes and build some equipment, they're going to put the laser, the sample cell, the detector, then they align the gonio so that at every angle, the detector is seeing the same point, right? So there's a technique that's a very laborious technique. You can take anything from half a day to 1 day depending on your experience, right? So our goal is not to have to align. Okay, so if nothing, you didn't do anything to this system, it should have no problem. So the way to establish whether the alignment is good is do a test, okay, which I'm going to do now. So before we do a test, we're going to make sure that the laser is on. I have put the laser power at 5 milliwatt. So you can, over here you can change the laser power. The power is 5. You can go up to maximum 30. So in the past, the equipment comes with a gas laser, the argon or neon depending on the wavelength, 488, 514 or 630, something like that, 633. Okay? So this is a diode laser that's longer life, right? So it can last many years. And the diode laser advantage is that you can change the power. Okay, so now, so if you want to have high scattering, you increase the power, one, or you increase the pinhole from 200 micron to 3000 micron, or 0.2 millimeter to 3 millimeter, right? So the bigger the hole, the more light goes through. And then the detector has a filter that only allows the scattering from the laser wavelength. In this case, it's 676, right? 636, right? So I put it 636 now. So now is at 1 millimeter. The thing is set at 666, right? So whenever you put sample, always close the laser, because when you introduce, you can see, you can look here, right? When you introduce a sample, as the glass goes in, quite a lot of reflection. The reflection can damage. So, right, so that put this. So now, okay. Let me turn this on. Okay. So I put the laser on. Right? So let me increase the laser to 25. Okay. You see the right? But not so much sparkle. There's so little sparkle, right? Sparkle, when there's a sparkle, that means that like spark, right? Something is interrupting the light and it's scattering light, right? So when you push this in, as you push in, you can see, right? The thing is going down, right? So the inside there's a solution called depthing. There's a C refracting index as glass. Hence, at all angles, when it's curved, the detector doesn't see the path. Right? So that's a trick that we do with the system. Okay? Any question? Okay. So now we have set up we have polling, and then we set the detector at 636. Okay? So now I want to test to see whether I've set the pinhole and the laser correctly. So I want to have scattering in the range of 50 kilocounts per second to 200. Because when you change angle, the scattering really changes. It's a function of angle. So now, to do that, you can do an intensity check, right? You press here, intensity, and then it should give you, so it's 0. Why is this 0?
Is it closed?
The pinhole is open. So something is wrong, right? There's no signal. So when there's no signal, either the laser is not on, okay? The filter is closed, or there's no power. Okay? But right now, there's no power because the power is here. Detector needs a power, right? So if I put a power, and I try again, still nothing, right? Right. Yeah.
Yes.
Okay, so now it has 90,000.
Yes.
It's good, right? So now we know that the detector is working. Okay, so let's say if I set the laser now to 5, before it was about 70,000, right?
Yeah.
So I set to 5. Okay, so I measure again. This should drop. Now it's about 20,000.
20K.
Okay, so I can increase this to 3, right? And I measure. It should be higher or lower. The pinhole now is going to from 1 to 3. It should be higher, right?
30K.
No, it's not true. Let me see. Let's try again. So 28K. So now I'm going to drop it down to 1. This is interesting. So I put it on 2. Yeah, so it's very low, right?
Okay.
So I think for 1 to 3, maybe there's not a drastic because the pinhole is open. So let's say 1. Okay. 20,000. So I'm going to move the laser now to 25. Okay. Okay. So the last time we do the angle, so you can edit the angle, you can load the angle. Okay, you can load list. I set up a list the other day. I set up 2024.
Yeah.
So you can save the angle that you want, and then you open. So this is the angle that we set up the other day.
Yeah,
Right?
yeah.
So I want to just run to check, right, the alignment. So there's software called goniometer alignment software. You open it, it would show you can change the angle. Okay, and what this thing does, the person who designed this instrument is very smart. So the detector, you can set the parameter, right? Parameter say every 1 second it measure, right? Kilocounts per second. Every 1 second it measure. Then it gets the number of count. And then you can set how many times you want to do the, so in this case it's 10, right? So what this thing does is that it when you do that setting, it would count. Every 1 second it counts, so you just measure, right?
Yeah.
And then if your thing is very clean, then every measurement should be good. But sometimes if there are dust, you measure dust, then instead of 20,000, you get 70,000. So that number is error, right? So the software can then remove that, remeasure, remove anything higher than the average, right? So I want to show you the importance to make sure that, as you can see, right now it's pretty good. So yesterday, so they also built that because you take your glass, you put it, every time you do that, you introduce dust. Right? So if you, before you do any measurement, the first thing you do is to clean. So there's a pump that pumps the thing into it, and then through a filter, 0.2 micron, and then it cleans it. So if I turn this on, right? So you can see, eventually it should be cleaner and cleaner. So you're going to pump for, let's say, so make sure that this is off, right, when you do the pumping. So let's run it for 1 to 2 minutes. One problem is that sometimes the filter breaks. This is not a very good setup, right? It's a lot of work to change the filter. So if filter breaks, then you can't feed filter, right? So if the filter is working within 1 to 2 minutes, it should be good. So occasionally the amount of declin drops because you are cooking enough, right? Then you have to fill there's some declin in the chemicals cabinet. Fill it up. The way you know is that when you pump, you see a lot of, that means there's air going in, air bubbles. You can tell, right? So this is off. So today we'll do the dynamic light scattering first, and then the static light scattering, right? The other thing that we have been trying to work out is how to measure the rod particle, right? So if it's a spherical particle, they are isotropic. That means every part is the same. So when it diffuse, it's scattered light, right? But if it's a rod like CNC, it would diffuse and refuse, right? That's a rod. So the instrument allows us to measure both the rotation diffusion and the translation diffusion by changing the polarization of the detector. So there's a thing here you can change. Let me see. Okay, I'll show you afterwards. Okay, so there's a polarizer here. There's a magnet. Yeah. So you can see two arrow. This is VV, vertical polarization. So if you move to 90 degrees, then because the wave has this and this, right? So you can use the polarizer to only pick up, just like you wear your glasses, right? The polarized lens allows you to see one. Okay, so make sure that always is this two arrow point. Okay, I think it's good enough. So I turn this off. Right? So now I'm going to open the filter. Always make sure the filter is at 636.
676. Yeah.
Yeah. Okay? So now I just check if everything is good, the intensity is good, right? Okay?
87.
So now we are good. So I'm going to press OK and the system will run immediately. Right? So now
Start.
Okay? So it's going to pick up, right? You can see, right? They are close to 87, right?
Yeah.
So the more, okay, one shot, you don't even have to remove, right? That means that the thing is clean, right? So now you go to the second angle, right? You can see 61, 62. So if there's no removal, that means everything is good. Yeah. So remove the higher one. Yeah. Okay.
So it's different angles.
Yeah. So you do the angle that we said, and then ultimately you plot. If the difference is plus minus 2 to 3%, then you're good. Okay. So the less repeat that it does, that means that your sample is clean, your detecting is clean. If you use taurine, you no problem with dust because taurine is hydrophobic. If you use water, then dust, which is micron size, can be dispersed in water, and that's where the problem is. Most of our work is with water, right? So the proportion is very more challenging. This Dr. Chibu in Hong Kong, he has a cleaning where he even cleaned the thing, so he has something that he pour a vapor or acetone, they invert and then he cleans the thing, and they cap the tube, and then they fill the tube when they have the sample. Right? So you can see when they do I prime times sine theta, it should be the same. Right? Because solvent is a small molecule, it has no angle dependence. So that's why they use taurine to do the angle. Yeah.
Yeah.
So always remember, we're going to do the dynamic set light scattering from 30 to 150. So if this extreme angle has some error, it's not a problem because we don't look at those angles, right? Any question?
Angle 30 is your big.
44. No.
So the 30 is
30.
Yeah.
the numbers is
No,
big.
no, this one you're going to see.
Oh.
Yeah. So you remove this.
Oh.
You can see, right? This. So very good, right?
Yes.
Okay. So everything is good. We save this. So today is 9 of
10.
10 of May.
10 of May.
Okay?
Okay.
So we have checked the alignment is good. Okay? So we can do the straight line scaling now. Okay, so you remove this, exit, and then you go to, so there's a software here. Let me see. Here's the,
All programs.
all programs. Okay. So there's a box that gives a BROOKHAVEN, and then you just go to line scaling, dynamic line scaling.
Dynamic DLS.
Okay, so this is the setup. Okay, remember setup. So what happens is that the layout, you press layout. So here, the two things that you need to be thinking about is this. Okay, first delay. The smaller the number, the smaller the size. So let's say if I bring this down to, let's say, smaller. Okay, let me just try what is it, then you can see what the number, right? So let's run. Right? Okay, so there's a I can override it if I want to cancel, then you run, right? So this is the, so if there's nothing that you got to put function list and then activate it. So I've got to get the ground. Then rearrange my time. Okay. Okay. So there's nothing there, right? Because this is solvent, okay?
Yeah.
So I'm gonna turn it off. You shouldn't get any scattering because it's solid, right? So now I need to turn this off, close it, and I put your polymer. Okay? So every time you take it out, clean. Which polymer you want to
These ones. So I have 4 concentrations. This is the lowest. This is the highest.
Okay, this is what
Hydrogen in acetic acid solution.
okay. Just that. So the scattering is 42,000, right? And what I'm puzzled is why is there such a right? There's a very I can see the laser going through and there's a lot of refraction. Right? So yeah, you can see this is what it does, right?
Okay.
Yeah, I'm puzzled as to why. Is it just not fast or? So I'm not seeing a lot of scattering, and I can see the spark inside the right. So that means that the amount of scattering is not very high, right?
High.
Yeah.
Is concentration too low?
Looks like it, right? Okay, let me prove to you.
我看提供这个系统。
Do we have a CNC dispersion? Yeah, can you bring some? Oh, okay. Let me just change the laser power to 25 and see. Okay, sure. Okay. Let me just try. Okay. Yeah. So what's happening? It's only 1 kilocount, right?
So the laser power is too low?
No, after the 25.
Okay. The pinhole.
Yes.
The pinhole
You
number.
see it's close.
Oh,
Right?
it's close.
Yes. Okay.
Yeah.
Okay, this one.
Too concentrated.
That's okay. Afterwards, you see like a put aside first. Okay. So 238, right?
Yeah.
See, for polymer, you see, the thing is that for polymer solution, it's very difficult to measure the size.
Okay.
The reason is because the size of a polymer coil is very, very small, right? Compared to particle. So I probably would not do dynamic line scattering for now unless you want to prepare a 0.1% CNC. Yeah.
So can we do like static?
Yeah,
Static?
static scattering,
Yeah,
that's right,
static
yeah.
light stirring for
Okay.
polymer.
So always make sure you shut off before you.
Yeah.
So let's see. And let's do scattering. So what are these sample here?
Kaizen. It's all Kaizen solution. These are filtered by membrane
Oh,
after,
okay,
and,
okay.
and these are filtered by filter paper.
Filter paper.
Yeah, the paper.
But the Kaidosan, the problem is I said the Kaido
Yeah.
will bind, right?
应该是传统，对。
对。
You can see how much scattering that is, right?
Yes.
Right? So these are, right? You can see a lot of scattering from the laser, right? So the way to do it now, I'm going to drop it down to 5. Right? This is the thing, right? If you do the size, right? Size is big, you get a lot more scattering because I is proportional to D to the power 6. Right? So I'm going to do dynamic line scattering, okay?
Okay.
Okay. So let's set it down to lower. To 5 million. Too high, right?
Yeah.
So straight away you can see this stuff. Very nice graph, right?
Yeah.
Okay. So okay. So that gives you a size. Here it tells you you can change the layout. You can change the data to give you a size, right? Of the so once you get this nice exponential function, then you know that your data is pretty good. So remember I said to you this is the setting,
Yeah. Delay.
right? So I'm going to change it to show you. If I reduce this to, let's say, 0.1, it will just measure at shorter time.
Sure.
So this is the delay time, okay? So I should do a course to explain to you how there's an autocorrelator inside the equipment that does the analysis, right?
Yeah.
Okay, so this would be the size. So this is just one of the software, right?
Yeah.
You can use a different software to do the analysis, right? So let's say if I don't even use the content, what is this analysis software, and then you just do a smart tile. So this is the size cursor, right? Right. So there's area somewhere. So it's the analysis that gives you this size. You can change it to let's say influential function, right? It's a different analysis software that do the measurement, right? So this maybe there's a size here, right? So the one most common is NNLS because you can do both the these two are the most popular. So let's say we just do this, and then okay. So let's say the effective average is about 148 diameter. So that's about rough, right? Okay. So let's just clear, and then I want to show you how to do the layout, right? So this is the delay. So this delay time range is the bin to the range you measure. So small time is very small per particle. So if I do, let's say the smallest, that means you can do very fast. So this is the smallest, right? Okay, and then I show you what happened. So see, it's going to measure. So this is flat. So there's no need to go down to here, right? You can see you go down to here is good enough, right? You know what I mean? This doesn't give you any more data, right? So the very short term always have problem, right? But So you can tell once you do that, you know that you don't have to do to here because it doesn't have very, very small size, right? So it doesn't give any data to correlate. So if you start around here, right? So let's say about 1 is good enough, okay? And then this is already flat, so you don't have to go to too high, right? So let's say that's how you decide, right? So now you set the layout. So now I want to go from 1, or let's say 0.2 to let's say 4, right? And then you run it. Right. So now, right, you can see, right? Because this data, so there's a baseline here. So now you get a nice curve, right? You want to go even, so let's say you have a small size and a big size, then you're going to get this, right?
Yeah, different
Yeah,
different
exactly.
speed. Yes.
Right? Yeah. So that's just the way we have tried to do it. So this is the size, about the particle size, right? Okay, so when I finish, I want you to do multiple angle, and I want you to do this. Right, so let me explain you what happened, okay? So deliberate scattering, what it does is that it measures the noise intensity as a change in time. In the noise, there's a unique diffusion that comes with this noise, right? So they take this thing, this noise, just like stock market, right? It's noisy. Embedded in the stock market is a trend, right? So you take this, that's how they do it for machine tool, for pumps, right? They operate with frequency, then there's a tornado pump things chain, right? So then you correlate to get this. So to convert this density time function to correlation function. So this function is a correlation of the data here. So how it's done is it does it. So remember the delay time. So these are very small time. You can snap the beam to different time. Okay. Remember I said from 1 to 1.4. So once you set the beam, then you start counting, right? You get a correlation function for tau 1. Tau 1 is, so this red line are the intensity. Just take a stop, take a stop, take a stop. So now you have all the data. Then inside the computer correlator that can do to get the C part. So the first short time that you set, you just 1, 2 times 1, right? 1 times 3. So it correlates the data at 1 time spacing, delta t, right? You have all the data there. It could be 50 channel. You can correlate. C2 is 2 spacing. This times this times this, you correlate. And then you get this function. Right? It's done in the software. So that one cut costs $20,000. So that's a half of the instrument. Okay, so once you get this, then you can do math software analysis. So you do correlation, you transform this into a distribution, and then this is time, and then from there, this peak is tau. You plot gamma you want on tau versus q squared, which is this square, and then you get a straight line. But if you use Dr. Liu's instrument, it measures one angle. The positive is 0, 0. So if this point is wrong, the slope is wrong. If you have 4 points or 6 points, you are guaranteed that your measurement is correct. Right? And the slope is dt. Right? Okay? So that's what I want you to do afterwards. You're going to use 6 angle. You're going to get this. You're going to plot this up. And then get DT. Once you know DT, you get RH, right?
Mm.
Okay. So for my student, he was making this 4-arm system. And then get very complicated here. So you're able to use it to explain my point. Okay, so now, so this is done. Okay? So I want you to after to do 8 angles
Yeah.
from 30 to 150. Okay, so all you're going to do is, so this angle is 150.
Yep.
So you save. Save project function as. So now you're going to create. So we want to database, right? So I want to create. Do you have a database there?
No.
Okay. So let's create a folder.
Okay.
Okay. So lens folder is here. Okay.
Yep.
So you click. Now you exit. Right. So now you save. Coding function. You save boolean. Right. So now you put 150 degrees. So this is
CNC
CNC 150.
50.
Okay.
Yeah.
Okay. So now you move the angle. So you save, right? So now we're going to move, control, motor, set angle now. The one function. Okay. We have saved this, right? So I clear.
Yep.
And then control. So current angle is 150, right? So I'm going to move to 130. Okay. Okay, so now you just do the measurement.
Yep.
And then when you finish, you just set 130. Okay. So after you finish, so let me explain. Do you have pen? Okay. So you just do 150, 130, 120, 105, 90, 75, 60. Okay?
Yeah.
Maybe 45. Okay? 8 angles. And once you have done that, I want to show you how to do VH.
Okay.
And then from there, we can analyze the data for the. Okay?
So how do we know if one measurement is done?
It shows your time.
Oh,
So we
okay,
set
okay.
2 minutes.
Okay.
We can. So once you get a nice crossing curve, that means you keep on longer time. It doesn't improve.
So we can save it anytime, like if and
No, the best is just wait 2 minutes
Oh,
because
wait,
you want
2
it to be the
minutes.
same, right?
Okay,
So this is good. We have the nice curve,
okay.
right? And then you can analyze the data. I show you how to export.
Okay.
And then we have a software there.
Okay.
Did you know there's a software that okay,
I don't know.
after we'll so we're gonna do the VV and VH first, and then
Okay.
I'm gonna see the software.
So we save the